this method of testing can tell you not just, yes, you have diatoms, yes, you have dinoflagellates, it tells you how much and which kinds. So based on the DNA levels, we found low levels of dinoflagellates in your sample. They were amphidinium. It can be useful to know which type. In your case, there wasn't a lot in the sample, and it sounds like you had already kind of defeated the dinoflagellate problem.
In today's video, we're taking a look at the tank DNA results that I got back from my 125-gallon reef tank using Aquabiomics. We're gonna jump into a conversation that I had with Dr. Eli and talk about some of the goals that Aquabiomics has as far as how long does it take to get a test result back when you submit your samples. We're gonna jump into all of that and more, taking a deep dive into my reef tank's tank DNA. So without further ado, let's jump right into it. Yeah, and with these tests, one of the goals, I believe, is to have a little bit quicker results. Is that something that you're working on?
Yeah. Let's talk about that, kind of the development of the testing service. Yeah. So the point I always like to start here is, in the academic world where I come from, these tests are done on a time scale measured in months to a year. Usually, when a researcher hands off their sample to someone, they're happy to get results back in about a year, sort of for their big conference next year or whatever. I knew that wasn't going to cut it as a service, right? So I've made a lot of efforts to really make this go as quickly as we can. But the turnaround time has always been the biggest challenge. Hobbyists want the results tomorrow, and the facilities that do this kind of work are expecting to give you results back a year from now. What we have done in phase one, that is Aquabiomics, up until about a few months ago, we were doing 1 month turnaround time. Every month we processed a batch of samples. And so depending when your sample got to us, your turnaround time could be less than a month or around a month. And the reason for that, it's not just that we're lazy or limited by resources or something. It's the technology. The DNA sequencing machines, you can't just put one person's sample on there. You need to put enough samples on there to make use of all the data that you're going to get back. And so, that was the limitation. It was just about, we need to get enough samples to fill the batch. And in the early days of Aquabiomics, the first couple of years, that meant one batch a month. A batch being maybe 50 or so, 50 to 100 samples, depending what kind. Over the last few months, say half a year or so, boy, we've been so busy. We're now running 2 batches a month consistently. And so this is without any changes in technology. We're just working more, just working more hours. We're now running 2 batches a month. So again, depending when your sample gets to us, you could get your results less than that, but generally it's going to be around a 2-week turnaround time.
Yeah.
So I think clients should really, keep that in mind in terms of using the service. It's a good idea to have your tests on your shelf already before the problem happens. Because, when you place your order, let's say you have a sick fish, you have an algae outbreak, whatever the problem is, when you place your order, well, you've got to allow some time for us to ship it out to you and the postal service to get it to you, right? So there's some time passed. You would save that time if you had the testing kit already on your shelf. So that's one way to minimize turnaround time. Another thing you can do, depending on the nature of your sample, whether it's an emergency or not, you could think about our testing schedule. So these days, what we're doing is the beginning of the month, the end of the month and the middle of the month. Okay. Those are our sample deadlines. So, if you get your sample to us right at the middle of the month, say like the 14th or so, that would be right before we begin that batch. Do you see what I mean?
Yeah.
So you would have the shorter turnaround time. And again, you'd have another sweet spot at the end of the month. Get it to us right before the end of the month, and we'll start processing it sort of right away.
Yeah, so definitely be prepared, have the kit, and then know the timing of the schedule.
Right.
Yeah.
Yeah. So that exactly it. Those two things are the best things the user can do to minimize their turnaround time. And the other thing that you can do is just, be aware of this schedule. So plan ahead. Don't try to use the service as something to get an answer tomorrow. But things don't always happen quickly in reefing anyway, right? You get your fish, you put it in a quarantine tank. You're probably going to leave it in that quarantine tank for weeks to perhaps a month. Well, that's the kind of time frame of our testing, right? So I think if the user just thinks about it that way, as I'm going to test it and then wait a month, which is what we have to do with a lot of things in reefing. If you go into it with that expectation, you will be happy, because we will be able to get you your results within that time frame. But
because
overnight results aren't going to happen anytime soon.
Yeah, because in some cases you have like a fish breaks out with something like at that point you're able to see what it is. If it's like cryptocarin or like ick, you can see that. You can make the judgment. You don't really need a test to tell you that you have it at that point. So this is kind of like, you want to send in your test to see if you potentially might have something, and then you can proactively, like, you can get on it before it goes south.
Yeah, that's right. Yeah, so it's all about planning ahead and taking the samples in a time frame that's realistic for the testing. So thinking about the fish example, imagine you got in a new fish and you put it in your quarantine, and you don't see any symptoms, right? You don't know, is that thing infected or not? Well, go ahead and test it. Test your quarantine at that point. After the fish has been in there a couple of days, go ahead and test your quarantine. And then when we give you your results back and tell you that tank was clean, maybe you don't need to wait so long before you put it in your tank, in your display. Do you see what I mean? You could use it. You could use it in conjunction with a quarantine to evaluate whether there is an unknown disease. I think it's equally important to test the tank. So, a lot of us pay a lot of attention to the fish we're putting in our tanks, because we're aware that, if I put this fish in and it introduces ick into my tank, it could wipe out my tank. But there's been less discussion of the opposite. That is, there's already stuff in your tank that could pose a threat to that new fish. And so it's useful to test the tank before you put the new fish in. And that we have a lot more flexibility on the time, right? Test your tank now, and once you get the all clear result, go ahead and buy that expensive fish that you've been wanting to buy.
So like in my case, I can add a fish to the tank. I just probably don't want to add a seahorse or something to it.
Yeah, that's right. I mean, take the information you got and make the right decisions with it. There are other pathogens and parasites that if I saw them in your tank, I would say, just don't buy any fish for this tank, right? We get people back with such high levels of ick in their sample. I certainly at that point would not add any fish to the tank.
Right, yeah.
But that's a very different situation than what we found in your tank,
Yeah, very cool. So do you want to jump into the tank DNA test report?
Sure, yeah.
And there's some interesting things that popped up in there. So let me add that here.
Yeah, great.
So this is...
so again, it's DNA sequencing, but here we're just sequencing DNA from different organisms in the tank. We've targeted the eukaryotes, and that's really everybody that's not prokaryotes. So if it's not bacteria or archaea, then it's in this report. And that's not an artificial distinction in terms of, well, we just split it up. I mean, we do an entirely different process in the lab in order to get the two different kinds of data. So one of the groups of eukaryotes that we can find here that we're interested in are the nuisance algae, like dinoflagellates and diatoms. And so this this method of testing can tell you not just, yes, you have diatoms, yes, you have dinoflagellates. It tells you how much and which kinds. So based on the DNA levels, we found low levels of dinoflagellates in your sample. They were amphidinium. That's one of the well-known groups of dinoflagellates that lots of people discuss in the hobby. And, you know, there are different treatment options discussed depending on what kinds of dinoflagellates you have. So it can be useful to know which type. In your case, there wasn't a lot in the sample, and it sounds like you had already kind of defeated the dinoflagellate problem by that time.
Yeah, I was on my way out of getting rid of them for sure.
Yeah, cool.
And yeah, so that definitely kind of answered for me what type I found in the reef tank.
Yeah,
I was just comparing off Google, and yeah, here it is in the results.
It's great having those two lines of evidence, you know, the visual confirmation and the DNA. At that point, it's hard to debate was that it.
Yeah.
We also sometimes find, you know, toxic dinoflagellates or parasitic dinoflagellates. You know, some of the fish parasites show up in this group, and there are also sort of toxic algal bloom types. None of those showed up in yours, just a little bit of amphidinium. If we scroll down, I mean, we saw diatoms, but there were no unusual types, just high levels. In this sample, we found high levels of diatom DNA from one type. Very common type. I wouldn't be concerned unless you are seeing an outbreak, in which case you might take this information to say, maybe I have a silica issue, or maybe I just need to do some sand vacuuming.
Yeah, I think I need to do a little more cleaning up on the sand and the rock work for sure.
It's funny. I mean, I spend all this time working with high-powered computers and sequencing DNA, and often the advice I end up giving people, or the suggestions I end up giving people, are so dumb. It's like, well, try vacuuming your sand.
Yeah.
So I shouldn't say dumb, but such a low tech, you know.
And a lot of times that gets overlooked, right? Like in the busyness of life. Just day to day, like, okay, I should probably vacuum the sand.
There's no substitute for physical cleaning.
Yes,
manual removal. So we can scroll down and look through all the other stuff we found. You know, so it really does just find all of the eukaryotic DNA in your tank. And so looking at this list, I can see that we have fish in this Actinopterygiae group. We have fish. We have sponges. I see snails, copepods, worms, and then it kind of goes off the screen, so we can't see more. But the point, just while we're looking at this, is to say we see a wide range of animals. I just named a few that are consistent with what you'd expect to find in a saltwater aquarium community.
Yeah, and you had sent me a message that you found like an odd, I think it was the gastropod or something that like that. You found a DNA that you don't normally see, and you were kind of wondering what that was.
I remember that the snail in your sample was an unusual one. Let me pull that up and see if that's the. Yeah, I was just looking at your result again today, and I didn't spot any unusual parasites or anything, which is always good. We do sometimes. Oh yeah, here it is. So actually, it's a nudibranch. We found a nudibranch.
Oh, okay.
So yes, you remembered correctly. It was gastropod. It's not a snail. It's a nudibranch. So I'm not at all confident about the species ID on that nudibranch.
Okay.
But the higher level, family level classification, I would stand by. So it does seem to be indicating the presence of some kind of nudibranch. It is not one of the known parasitic nudibranchs.
That's good.
There's only a couple of them that we know. It's possible there are others out there. So what I'm going to tell you is that is a nudibranch. It is not one of the known bad ones, but I'm not entirely confident what kind it is. Okay. I can tell you what the DNA matched most closely to, but it could be a relative of that one.
Very cool.
Yeah, interesting. That's an oddball. So you don't know about the presence of any nudibranchs in your tank?
I mean, not that I've seen. No.
Yeah, they can be cryptic. You know,
Yeah.
we can find stuff. Certainly, a lot of the stuff on this list is invisible, right? You probably couldn't have told me about all the different ciliates that were in your tank either, for the same reason. You know, they're just hard to see. Yeah, that is an interesting finding.
Yeah, and then so what's the okay? So this is diversity and
right. So the first graph shows you the data in terms of diversity, and the second one shows you it in terms of abundance.
Right.
So in the second one, when you see a big bar, that means there's a lot of it.
Okay.
In the first one, if you saw a big bar, it meant that there were a lot of different kinds of it. Two different ways of evaluating sort of what was there a lot of in your sample. And yeah, it looks like in your sample, yeah, forgive me, in the one on the screen, it's hard for me to see, but if I go to the one on my screen, I'll be able to see the colors better. So it looks like there were two big dominant groups in your sample, and I'll scroll down to. So one of them was the Phaeophyceae. So this is a group of macroalgae. Okay. And the other one. The other one is diatoms. So the two big abundant groups in your sample are diatoms. We already knew that's the green one.
Yeah.
The big green one, and then the big blue one is Phaeophyceae, a group of macroalgae.
Okay.
Yeah, so that abundance information, I would not interpret that in terms of sort of counting organisms in the tank. You know, this is different than the microbiome, because think about in the microbiome, everybody has just a single cell, right? They're all unicellular organisms floating around. So you can somewhat count the DNA and infer how much of it is in the community. There's a lot of arguments to be had about those details among microbiologists. But in the eDNA world, it's very different, because we have multicellular organisms. You have things like a big sponge with billions of cells in it, right? You're going to get a lot of DNA from that thing. And then you have other things that are very tiny, and you'll get less DNA from them. So I wouldn't interpret this abundance in terms of the abundance of the organism. Really, it's just about the sample. It's just saying that we got a lot of DNA from algae, macroalgae, and diatoms in this sample. Yeah. I think one of the most interesting things in these reports can be when we scroll down and look at the complete table at the bottom. So I have so much fun. Every batch of samples I process, this is my favorite part, is when I get to see the tank DNA reports for the first time and get to look through all the oddball stuff that we find in people's tanks. So as you're scrolling through, I'm seeing Dinoflagellates. So that's a obscure little group of microscopic eukaryotes. Diatoms, we all know about diatoms. Here's that oddball gastropod. You see it's in the family Heterobranchia. So these family level designations are going to be very accurate. It's certainly some kind of a heterobranch. The Intramacronucleata. This group is the ciliates. We know these commonly as ciliates. That's their formal taxonomic name. And so this is a group that's important to look at because it has lots of parasites in it, right? That is the group. The group includes lots of parasites. We found lots of ciliates in your sample, both in terms of the abundance and the diversity.
Okay.
I don't know, a dozen or so. What is that, 8 or 10 maybe? They're all very common types of ciliates, but none of them are the parasitic kind. Okay. This is something I like to look at in the reports. I like to say, look, we sampled the ciliate community effectively. We got good data on the ciliate community, but we didn't find any of the parasitic types.
Yeah.
If I got data back and we just didn't find any ciliates in it, I'd be a little skeptical about claiming that there were no parasitic ciliates. So that's one reason I like to look through these tables, is to kind of verify that, yeah, we sampled this tank really thoroughly and still didn't find any parasites.
Yeah, no, I'm very fascinated with all the stuff that you're able to
So,
pull out of this water sample. So
yeah, I mean, it's
great.
it's great fun. You really can
Hmm.
find stuff you weren't even planning on. So, here's copepods, the maxillipod group. Um, so that's a very common kind of copepods in aquarium samples. Not a parasitic type, not any kind of
Hmm.
problem. But there are some parasitic types of coral copepods. So that's certainly something I look at every time I get to the copepod section and say, well, are there any oddball parasites in there? No, this looks clean.
Nice. And so, and with the reports, you also have the families and different things linked up, right? So that you can
That's
get more
right.
information.
Yeah. So
That's
this is something I'm constantly working on. That as time goes by, um, this part of it will improve. Um, that's in part because I will have the time to do more work on it,
hmm
and in part because we will learn more about things as we go along. So my default starting point with these is always just I wrote some code that says, well, if there exists a Wikipedia page on this, link to the Wikipedia page on it, because
Yeah.
that's certainly going to be a good starting point to learn something about. Um, but as I learn more about these groups and build pages for each of the specific groups, I'll have the code instead link you to the page on our website. So
Okay.
so I'd encourage people to always check these links. This really is a good, I'm intending to give the client all the information I can about each of these groups, and the way we're trying to do that is through the links rather than typing it out in an email.
Yeah, I think that's a huge benefit because then that helps us understand exactly what we're looking at if we're not familiar or we
Yeah,
haven't jumped into this micro world, and so
yeah.
we don't know all the terms and everything, so we can see
Yeah,
that.
and
So
and look, I taught invertebrate biology for a long time, but I don't
yeah,
know all these names, right? So I mean, when I pull these lists up, it's very frequent that I see something I don't know what that is, and I click the link and
yeah,
go down the rabbit hole learning about it. So yeah, so I'm that's high on my priority list to add more content to these links so that they can go to specialized pages on our website and give you more details, sort of more focused for
hmm
the aquarium hobby.
yeah, very very cool. And so if people want to get their own test, then they go to the website,
Yep,
which I have a link right here. So that's aquabiomics.com.
that's it.
And then you're also doing like live reef sand, and you're doing the rock rubble as well.
Right.
And the goal
Yeah.
with
So
that is to help seed the tank and get you on the
exactly.
right track. Okay.
Yeah. 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 It's something. Again, I think about this in terms of sort of dials and knobs. We test your community, you learn something about it, but then you want to turn a knob and adjust it. You want to
Hmm.
change something about the community. Um, so in the long term, my long-term plans for the company is that we will continue expanding on these things. We're very focused on testing right now, but long term, we want to expand on these offerings of products that you can add to the aquarium. Right now, there are so many of those products out there that it doesn't seem like the right strategy for us to you know make that priority number one of
Hmm.
being the newest bacterial supplement on the block. um, but what I didn't see a lot of on the market, I couldn't find any good source of live reef rubble on the market, live reef rock. So when I say rubble, what I mean is really just tiny little pieces of live rock. We're literally breaking it up and homogenizing it so that every cup is sort of similar to every other cup. Um, so it is just live rock. Yeah, when I started the company and I did an experiment on live rock,
Uh-huh.
demonstrating yet again what we all knew in the hobby, that live rock was a really effective way of seeding a diverse and typical reef tank community. I just couldn't find good sources of it on the market. There's all this crap that's purple dyed cement with some stuff growing on the outside of it.
Yeah.
It's not real live rock. Um, So we found a supplier and started selling this live reef rubble, which is just broken up live rock. The most important thing in my mind about our products, the live reef sand and the live reef rubble, the most important thing is the fact that it's tested, that it's known to be parasite free. It's really not a gimmick. About a half of the material we buy comes in infected with one thing or another. We had a batch of live sand recently, had both urinema and coral pathogen, Aqua-Rickettsia roweri. It's like double whammy, you know, both of them in one cup of live rock. Needless to say, we didn't sell that stuff. But my point here is to say that if you buy it from another supplier, it probably will be very effective in seeding a diverse community in your tank. You know, I have no reason to think that the other suppliers have any problems with the material, but based on my testing from multiple suppliers, I expect that a non-trivial fraction of the stuff out there in the market is infected with urinema mainly. Urinema is super common in the supply chain. Yeah, so we're offering those products as ways for clients to boost their diversity and nitrifying communities. That's really the situations where I end up recommending it, is if you have low diversity or low nitrifiers. I favor the live sand if it's an established tank. I think that's a more effective way of altering an established tank. And I favor the live reef rubble for a new tank.
Yeah, because if you get your results back and your results are less than desirable, like they're not, you're missing a group or something, or low in one way or another, you can add this tested live sand to your tank and kind of boost that back up.
That's right. Yeah. And so, you know, the report that you scroll through here, you see that these reports have in them some diagnostic information. It'll say things like, you know, we found cyanobacteria in your tank. Here's a link to some thoughts on how to deal with that. So we try to give you some of that advice in the report and in the links. But also, you know, for your listeners, anyone who hasn't had one of these tests done yet, you get that report back, but I also review your report myself. I review your data myself and send you a personalized email with just, you know, my interpretation of it. You know, and people in the reefing hobby are very, very well informed, you know, scientifically minded people often. So it's not that I'm trying to teach you, it's that I may have spotted something you didn't. You know, I may have spotted an oddball parasite in there. And I also have a different perspective because I look at so many of these tests. I have a perspective where I can tell you, okay, that thing we found in your tank, it's actually really common. I wouldn't worry. Or, wow, that thing we found in your tank is terribly unusual. And, you know, we should think about it. So, so yeah, you won't be left alone to make sense of it. I will try to assist.
Yeah, that and that is really awesome. I very much appreciate that, getting the personal email with all the other information, and it's definitely beneficial. It's really cool.
Yeah, it's an interesting process. You pull up these reports and, you know, have to sit there and make sense of them. And if it takes some effort for me when I wrote the code for them and spend a lot of time looking at them, then I know it must take some effort for the end user. So I want to help any way I can.
Yeah, so that's awesome. Aquabiomics, it's really cool what you're doing over there, being able to make sense of what a healthy microbiome is, and telling us if we have any fish pathogens or anything that can go awry in our tanks. And it's a new way of looking at things versus just what we can see and just thinking that it's water chemistry versus maybe something that we can't see that's causing an issue. So the best way to get a hold of you or to get their kit is simply go to the website aquabiomics.com.
For anything related to ordering, just go to the website, place an order, and if you run into any problems, of course, contact us through email. The website is the address is on the website, but it's easy. It's contact@aquabiomics.com. So place an order, shoot us an email if you run into any issues, and looking forward to seeing what's in all of your tanks.
Now, I don't know if that blew you away like it did me. The world of the microbiome and the tank DNA, the results that you get back is fascinating to say the least. This is part 3 of a 4-part series. So if you want to check out the other videos in the series, go ahead and click right here. And if you want to check out the entire conversation at full length, click on this video right here. Thank you so much for liking, subscribing, leave a comment down below, and I will see you in the next one.